Right now, as you watch this video, trillions of invisible particles are streaming through your body, moving close to the speed of light. They were born in the hearts of dying stars and the chaos of galactic collisions, millions of light years away. They're called cosmic rays, and they are silent messengers from the most violent events in the universe. Cosmic rays are not actually rays in the traditional sense, like light or X-rays. Instead, they are the shattered remnants of atoms, primarily high-energy protons and atomic nuclei, launched into the vast emptiness of space with incredible force. Their journey begins in the most extreme cosmic environments imaginable, exploding stars known as supernova, the super-bright cores of distant galaxies called quasars, and the swirling gravitational whirlpools around black holes. These cataclysmic events act as colossal particle accelerators, flinging these atomic fragments across the galaxy at nearly the speed of light, each one carrying an immense amount of energy. For millions, sometimes even billions of years, these particles travel through the interstellar medium, traversing the immense distances between stars. When they finally approach our solar system and barrel towards Earth, they encounter our planet's first line of defense, the magnetosphere. This invisible magnetic field generated by the molten iron core of our planet acts as a planetary shield, deflecting the vast majority of these incoming cosmic particles and protecting life on the surface from their intense radiation. But this shield isn't perfect. A small fraction of the most energetic cosmic rays manage to punch through this protective barrier. When these primary cosmic rays do break through, they collide with atoms of nitrogen and oxygen high up in our atmosphere. This initial impact is like a cosmic break shot in a game of pool, triggering a spectacular chain reaction. The collision shatters both the cosmic ray and the atmospheric atom, creating a cascade of secondary particles that rain down towards the Earth's surface. This phenomenon is known as an extensive air shower. Among these secondary particles are pions, neutrons, and a particularly interesting particle, the muon. Muons are like heavier, more ghostly cousins of electrons. They are uniquely adept at penetrating matter, capable of passing through hundreds of meters of solid rock, deep into buildings, and yes, even right through you. In fact, at this very moment, hundreds of these subatomic ghosts are passing harmlessly through your body every single second. For the most part, this constant silent bombardment of muons goes completely unnoticed. They interact so weakly with the matter in our bodies that they typically pass through without leaving a trace. However, on very rare occasions, one of these high-energy particles, either a primary cosmic ray that made it through, or a particularly energetic secondary particle, can strike an atom within one of your cells with significant force. If that particle happens to collide with a molecule as crucial as your DNA, the consequences can be significant. Much like exposure to X-rays or other forms of ionizing radiation, a cosmic ray impact can physically break the delicate double helix structure of your DNA or alter a single chemical base pair in the genetic code. This change is a mutation, a tiny, permanent cosmic fingerprint left behind inside the very blueprint of your cells. Fortunately, here on Earth, we are remarkably well protected. The combination of our planet's magnetic field and its thick atmosphere absorbs the overwhelming majority of this cosmic radiation, ensuring that the dose we receive on the surface is incredibly low. Life on Earth evolved under this protective blanket. However, for those who venture beyond it, the story is very different. Astronauts living and working in space, such as on the International Space Station, are outside the densest part of the atmosphere and travel through regions with weaker magnetic shielding. Consequently, they are exposed to far higher levels of cosmic radiation. Studies conducted by NASA on astronauts have shown that this prolonged exposure significantly increases their risk of accumulated DNA damage and mutations, which is one of the most formidable health challenges for long-duration space missions to the Moon, Mars, and beyond. Looking at the bigger picture, this cosmic rain has been falling on our planet not just for decades, but for billions of years. Throughout the entire history of life on Earth, cosmic rays have been striking organisms, introducing random changes into their genetic code. Many of these mutations are neutral, having no effect. Some are harmful, potentially causing diseases or developmental issues. But every so often, a mutation might introduce a beneficial new trait. It's a novel adaptation, or a new capability that gives an organism a slight advantage in the struggle for survival. Over geological timescales, this slow, steady drizzle of cosmic mutations may have been a subtle but persistent engine of evolution. It's contributing to the incredible diversity of life we see today. In a very real sense, every living thing on this planet carries within its DNA a hidden record of the cosmos, a history written by particles from distant dying stars. We are connected to the universe, not just by the starlight we see, but by the very particles forged in those stars. So next time you look up at the stars, remember, the universe isn't just out there, it's inside you. The atoms in your body came from stars. And the rays from those stars still shape who you are. No magic, just physics.
Stay curious.